today is we're going to walk through how to make a solution first, right? Like the physical making an actual solution. So what I want us to do is our goal is to end up with 100 mils of a 0.4 molar NaCl solution. Okay? Yeah, go ahead and write this part down because I'm going to walk you through the steps of actually making the solution because you're going to need to know that. SLN is an abbreviation for solution. Okay? So if I want to actually physically make this, right, I have my materials up here. I want to physically make the solution. What do I need to know first? What do I have to calculate first to get me started on making my solution? I need to know moles of what? Right, sodium chloride. But more specifically, right, what's really applicable to me for knowing how much to make? Moles or grams? Right, I really want to get to grams, but I need to go moles first. So if I go 0.4 molar equals X moles over 0.1 liters. All right, go ahead and grab your calculator out, periodic table out if you don't have those. That gives me 0.04 moles of NaCl. And so now I can find out how many grams I actually need to weigh out. 1 mole weighs 58.5 grams. Okay, so I think that is it's exactly how many grams of sodium chloride I need. Agreed? Okay. It just so happens that I have that much weighed out. Okay, conveniently. I have that much salt weighed out. So I'm going to walk you through now steps of actually making a physical solution. So watch and write these down as we go because you're going to have questions that ask you to write out how do I make this solution, right? Yes, I can. Okay, so first things first, calculate how much you need, how much solute you need. Second thing, okay, once we know what we need to prepare, we have to gather materials. Remember what this one is called? This one's called a volumetric flask. Okay, this is called a volumetric flask. It only has one marker right up at the top, and it tells us it's exactly 100 mils. Okay, so when we make a solution, we use this type of vessel because it gives us one volume marking. So if you go over the line, you have to start all the way over again. Because if you go over, you can't just dump it out because then that changes your molarity, your concentration. Okay? So this is a volumetric flask. So what we're going to do is we're going to put our solid into the volumetric flask. So you would need to find the appropriate volume of volumetric flask. So we could say, I don't know, get a 100 mil volumetric flask. Right, that could be like step one, right? You got to get the right volume of flask, and they don't come in every volume. So if I needed 150, I would probably have to make more and then get out what I need. You know what I'm saying? But you could say gather a volumetric flask. Step two would be to add solute. Oops, I can't spell. Add solute to our flask, and you can use a funnel. We want to make sure we rinse solute into flask. Okay, so I've got a funnel. I'm going to add that here, and I'm going to add my solute through the funnel. Okay, when we say rinse it into the flask, what's that mean? Right, we want to make sure we get all of the solute out of our weigh boat. We want to make sure we get it all off the funnel, right? We want to rinse that in there as best we can. Then we can remove the funnel, okay? Okay, from there you're going to add, I would say about half volume of solvent. Okay, so we're going to add enough water to get it stirred up, but not so much that we don't have room. Okay, because if we were to fill this all the way up to the neck of the bottle, there wouldn't be much room for us to mix. Okay? So if this was a chemical that was dangerous, I would put a cap on it, but it's not. So I just mix that up. Right, I've got about half my water in there, mix up until it's dissolved or really close to dissolved. Okay? The reason we don't wait till it's all the way full is because there's not enough room. Okay? Swipe your finger off so that anything on there falls in. Okay, but roughly that's pretty well dissolved. Then I'm going to fill, so the next step would be fill until almost to the line. This is going to sound weird on the video. Sorry, guys. Nothing weird going on here. Okay, so you're going to fill it almost to the line, and then the last step is add drop by drop until you hit the line, until the meniscus is at the line. So once we get kind of close, I'm going to slow it down.
Drop by drop what?
Till it's at the line.
Okay.
Okay, so you can add water or solvent, whatever it is, until close. Then finish drop by drop. And so all that means is that when we're close to the line, we got to get on eye level and make sure we don't go over. Because if we go over, we got to do it again. Okay, and so if you have drops on the inside, wait for them to settle, and then once you're finished, then you'll be done. Okay, so once you're done, the bottom of the meniscus should be at that line, and then if you can put a cap on it or put your thumb over it, you'll be able to kind of just up and down one more time to make sure it's all incorporated. As you're adding that water, it should incorporate itself well enough. But basically you're going to go kind of once over to stir it one more time. Okay, but this gives me a way to know that I have exactly 100 mils of solution. Okay, so you go here. When you roll it over, there's just not much action there stirring-wise. That's why we don't fill it up early. Okay, when you roll it over, there's just a couple bubbles that go, and then that's it. Okay, so I will have a couple, I think there's one question on your homework that asks you, describe how to make a solution, whatever, very similar to here. So you're going to walk through the step-by-step of that. It's not you walking me through the math steps, it's you walking me through the process of making the solution. Okay? All right, let's dive into what our goal is today, which is dilutions. And I'm going to show you a dilution here pretty soon. But let's look at what they are, okay? Dilutions are made from, bless you, what we call stock solutions. Okay, we get stock solutions, we order stock solutions from a company, and, okay, so these are made, we order a canister, or I don't even know what you call it, a jug, of different stock solutions, like acids and bases. We get them in some sort of container, and they're usually really concentrated. The stock solution is made to extremely precise degrees, and they're very, very concentrated. And then when I get them and we need to use them in the lab, I take some out of that stock solution, I dilute it down to whatever concentration we need it at, and then we can use it. Right? So for example, the bottle of nitric acid I have back there is 15.4 molar. And when we use it in the lab, we use it at like 0.1 molar. Okay, so it's significantly stronger than what we use it at. Right? When I dump it out of the nitric acid out of the bottle, it like steam and like just stuff comes out, right? And then you mix it with water, there's a lot of things happening, but when we use it in class, it's significantly more diluted. Okay? So we have to calculate how much stock solution we need, and we use this equation to do it. C1V1 equals C2V2. Any idea what these stand for? Volume is good. Concentration, good. And this concentration is usually molarity. Okay, so the 1 and the 2, what do you think those mean? Yeah, kind of before and after, but more so, this would be like the stock, and this would be the one we are making. Right? This is, if the concentration is 10 molar, we might need 2 mils of it to make a 1 molar or whatever. You know what I'm saying? Like, This is how much of one solution, and this is how much of the other. Okay? It doesn't matter which side of the equation these things go on, but one of them needs to be basically the concentrated version, and one of them needs to be what you're making. Okay? So let's look at some practice here.
It's not going to be 1, 1, and 2, 2. It's not going to be like 1, 2, or 2, 1.
Yeah, it's got to stay together, right? If I'm using 2 milliliters of my concentrated solution, those two need to go together.
But it doesn't matter what side it's
It doesn't matter if they're on the left or right. You just can't mix and match.
Okay.
Okay, so it says we need 500 milliliters of a 1 molar acetic acid solution from a 17.4 molar stock solution. What volume of the stock solution is needed? And so we got to figure out which one of these go together, right? 500 milliliters of a 1 molar acetic acid solution. Those need to be what I'm making, right? We need that much. So if I go C1, V1 equals C2, V2. Again, it doesn't matter what side you put it on, but I'm going to go ahead and put it over here because this is what we're making. We want to have a 1 molar solution, and we want to have 500 milliliters or 0.5 liters of it. Yeah. Right. So for this problem, it doesn't make a difference if you use milliliters or liters, as long as both sides are the same. Okay? Doesn't matter as long as both sides are the same. Technically, we should use liters if we're doing molarity, but it's really not going to be that big of a deal. Okay? And then over here, we want to know if our original concentration was 17.4 molar, how many liters of that do we need? Right? Or you could just leave it as V1 if you wanted to. Right? But we know we need so many milliliters of that concentrated solution. What is it going to be? Right? Usually when you're solving for that, it's going to be a pretty small number. So V1 equals 0.029 liters. Is that what we had? Multiply these two, then divide by 17.4. Okay, so let's think about the dilution that happened. We wanted a 500 milliliter solution, and only 29 of those milliliters are acetic acid.
Wait, so you divide the 0.500 by 17.4.
Right,
okay.
right. Okay, so in our 500 ml solution, only 29 of them are acetic acid. The rest of it's water. So it's been extremely watered down. Okay? 0.029. What volume of a 16 molar sulfuric acid must be used to prepare 1.5 mils of 10 molar sulfuric acid solution? This one's very similar to one we just did, so go ahead and do this one on your own. What volume of this, right? What volume of this? So that means this is what we have. What volume of that do we have? Right, so it should be pretty straightforward reading this one through. We want to end up with 1.5 liters of a 0.1 molar solution. I got it at 90094. Is that what you guys had? Okay. You can put it back to milliliters to give us a little bit more of an idea of what was really happening here. But it doesn't really make a difference. You can keep it in liters too.
What do you multiply? What did you do?
I multiplied these two together, and then I wanted VI by itself, or V1 by itself, so I divided 16 over. So I did 0.1 times 1.5, and I divided that by 16.
And you got, and so you got, for multiplying those together, you got 0.15.
Right.
And then you divide that,
by 16. You did 16 divided by.
16
Okay.
on top.
Yep. Okay. What's the minimum volume of a 2 molar NaOH solution needed to make this problem is the same as all of our other ones. Okay, I want to do a different one. Oh. Okay, I guess not. Let me give one more. This question is formatted the same as all of our other ones. I want to look at a different one. All right, let's try this. If I dilute, this one's not on your printout, sorry. If I dilute 175 milliliters of a 1.6 molar solution to 1 liter, what is the new concentration? Okay, if I dilute 175 mils of a 1.6 molar solution to 1 liter, what's my new concentration? Okay, so I take 175 mils of this concentration, and I want 1 liter of my new formula. So what is my new concentration? So I'd go 0.175 times 1.6 equals C2 times 1 liter.
Why wouldn't that be in the first part?
Which one?
The C2? Like, why couldn't we just do C1 times 0.175 equals 1.6 times 1 liter?
Well, because we don't want our 1 liter solution doesn't have a concentration of 1.6, right? I took out 175 of these milliliters of this certain concentration, and I move it over here, and I dump it in, and then I fill it up to 1 liter. So I want to know what's the concentration of my new solution.
Okay.
So I know the concentration of that 175. I don't know the concentration of my 1 liter solution. Okay? Yeah.
Don't you have to change one of them? Because one's milliliters and one's...
Yeah, I went ahead and did 0.175. So, yes. So 0.175 times 1.6 is 0.28 equals C2 times 1 liter. So if I divide by 1 liter, that means my C2 is 0.28 molar. Okay, I have one more here that's going to be a little bit more complicated, and then we'll call it for notes today, okay? So I'm going to write it out. This one's not on your printout as well. This one says, how many milliliters of a 5.0 molar solution must be added to 160 mils of water to get a 0.30 molar solution. Okay, so there's a couple key parts to this question. Let's go ahead and start kind of figuring out what we're looking for. How many milliliters of a 0.5 molar solution? Right, so that has to start out that this is our unknown, and this is our original concentration. 5 molar times V1. Right? Must be added to 160 milliliters of water to achieve a 0.3 molar solution. So here's the difference. In this question, is 160 our final volume? No, because it says we're adding this to it. So in our other questions it said to get 100 mils or to get whatever. This time we're adding a certain amount of volume to 160. That means we don't know our final volume, do we? But we know that our volume has to be V1 plus 160 or 0.160 if we're in liters. Right? So now we've got a V1 on both sides. Algebraically, we can still solve for that. Right? If I'm going to solve for this algebraically, I would end up with 5 times V1 equals 0.3 V1 plus 0.3 times 0.16, sorry. All right, you see I don't know what that's called, distributed that 3 through there, 0.3. Okay? And so now I combine like terms, right? Minus 0.3 V1 minus 0.3 V1, 4.7 times V1 equals 0.3 times 1.16, sorry, 0.08. Oh no, that's not 0.08. I did something wrong. 0.3 times 160. How about 0.48? 0.048. Wow, I don't know my calculator today. And so now when I divide by 4.7, the volume of my 5 molar concentration that I need to add to that is 0.0102 liters, or 10.2 milliliters. Right? That has to be added to that. So on this question, we just had a really specific added to. So we really need to think about bigger picture there in that my final volume is not 160. My final volume is 160 plus whatever volume I added. Right? But in our previous ones, we said we want a final volume of 1 liter or a final volume of 500 or whatever it was. Right? But this one said added to. That's a little bit different. Okay.